Hey people, um, it's been a while. Welcome back. Uh, Today I want to look at creating a navigable um, text menu using keyboard controls, using the cursor. So I'm going to create a menu and we're going to be able to navigate that menu not by pressing a button like um, 1, 2, 3, or some other key, but by actually navigating with the cursor. So I've been trying to go over this. I wrote this several months ago over the summer, and I really don't honestly remember. This was for Coco Ultimate, which was several months ago. I haven't looked at it in a very long time. Um, so I'm trying to understand the code here, and we're going to get started. Okay, I'm going to call this spells. So we're going to make some data lines. Okay, but we're also going to incorporate the arrow key. So it should be called arrow key. I don't know. I kind of incorporated all into one. So we're going to do this. We're going to make a data line. But first we need to clear the screen. And I think I'm going to make the screen, here I have it as yellow. I don't know why. We'll try that. And then we're just going to print spells. I can't spell today. Spells. And this colon is just like introducing the list. And then in addition to that, we are going to have a print. So before we start listing the spells, we'll have a gap like that, and the spells will be the following. And you can use this for anything. I'm just using it for this application, but you can make this to anything. So first we're going to have our data lines for the arrow. And we're just simply going to create an arrow of maybe like that. You know, this corner bracket with 3 dashes looks like an arrow. And then we need 4 dashes, 2, 3, 4, to cover up when the arrow moves down. And that's the actual graphic. And then we want to, well, in this case, I have a return option. I did this a little weird. I don't know if it should really be this way, but this is how I did it. You just do things the way that you can do them at the time. And then, you know, as you get more experience, you separate these items more carefully, but for right now, that's fine. That is going to be our arrow representation, and I'm going to pick, we have a move mountain spell, a kill spell, and that was it originally, but I'm going to add one more. Um, I had it in mind, and now I don't remember exactly what it was. This was so long ago. There's going to be a creature called a slime. So we have a snake and a slime. So how would we get rid of a slime? We can't use all of these spells on every enemy. They only work with certain enemies. So slime is sort of like a liquid substance. So we're going to use evaporate as a third spell, and I hope I spelled that right. No pun intended. Spell and spell. I'm just going to look this up. Um, I'm really detail oriented, so I want to make sure I spelled evaporate right. And all I have is a dictionary here, so we're going to go take a bit of time here. Evaporate, 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 evaporate. Okay. So the next thing we need to do is we need to read these statements. So line 6, we're going to call it read spells. So we're just going to we're going to say, since there's 3 of them, for A equals 1 to 3, and 8 is going to read a $sign. We're putting the $sign because these are all strings. But this actually, what we're going to do first, we're not going to use a $sign, okay? We're going to do this subscripted, and so this is important. We're gonna read arrow. We're gonna read arrow $sign. Now you can call your strings anything you want. Up. Okay, so I'm calling it. We're gonna place our information into. I don't know. It's a string, okay. But we're going to subscript it. So we're going to put our first data, which is this right hand arrow, left hand arrow, excuse me. We're going to put that into arrow $1. It's going to be subscripted. So the for next, it serves a purpose here. When you read data, you have to retain it somehow, and it's been a while, so we're going to read all of the data at once, so we need to subscript arrow $sign each time we read it, and it will retain the value of this, then this, then this. Okay, and to accomplish that, we're just going to put next A. Once it cycles through there, we'll have all of our pieces of the arrow, and I included return, but that will be listed. If I run this, it will be listed at the end of the spells. I don't know why I did it that way. I'm just doing it the way I had it. Then we're going to read, that should say read arrows. 6 should be read arrow. Alright, let's look this over again. First we're going to read the arrow, pieces of the arrow, and the return. Then we're going to read the spells the same way 3 times, and each time we're going to read spell, $, subscripted by A, and that will give us next A. That will give us. We'll put all of our spells into memory, and we're done. We're good for this. We're good on this. That's done. Now I need to make it function. So I need to give it support here, and this is where it gets complicated. We need to know if I just list the spells and I make the arrow go up and down, the computer has no idea about the relationship between the spell on the screen and the arrow, so we have to give it a relationship. And I don't know if this is the best way I could have done this, but it's the first time I ever did this before, so I did it haphazardly, and I'm gonna do it this way anyway, because it's the only way I know how right now. I'm just gonna literally copy my code. I don't remember exactly what it means. Sometimes you write these things and they're so complicated that it's hard to remember what it was in terms of, and so I have. But during the game, you're going to have to find these spells or earn them somehow. You might start off with 1. The rest of them you're going to have to find through experience or just by finding them. So there's something called, now line 14 is going to be called display. Display available spells. Okay, and depending on whether or not you have the spell, it'll be equal to 0 or 1. We're going to make all of our spells true. So spell and these are subscripted. Spell 1 is going to be true. It equals 1. Spell 2 is also going to be true, and it equals 1. If it was not available, it would equal 0. It would be false. And our third spell, which is the evaporate spell. So this literally translates in order: move mountain, kill, evaporation. But in the game, they'll be given these values, different number values here. And I haven't figured that out yet. Almost, this is like, I guess at the beginning of the game, I'll tell the computer that move mountain, spell 1 is equal to, I don't know. I have to figure out some way to make the string equal a variable. I don't know. It like kill equals, I don't know. It would have to be spell $. Spell $, would cover it. 1 would equal kill. Here I don't have the $, for some reason. I'll have to make a note of that. But for right now, we're just going to do it this way. And then once we do that, um, we have to make P, which is going to be our position of the cursor, we're going to make it equal to 32. So if P equaled 0, we'd be printing on this line. And then it goes in sets of 32. So the second line would be 32. So we want to begin printing at 32. But since I put that space in there, I think I have to make it equal to 64. So I'm going to do that right now. And so that sets the position of the cursor. Okay. And then we have to make y equal to something other than 0. So I'm going to make it equal to 1. And y is our up and down. I mean, yeah, left and right is the x-axis, and up and down is y. So then we have to determine that, whether these spells are true or not. We know that they are, but we have to determine which ones we have. And this is the second step to that. So this is really complicated. I don't know how I came up with this, but I wrote it down and I got rid of the paper, and luckily I just have this left. But we're gonna after this I'm gonna run it. So now we have to actually display these spells. Alright, so this should be called display spells. And 14 should be called available spells. I don't know what happened there. Jeez. Alright, let's list this over again. So these are the available spells, and then we display the actual spells. So we know that there's 3 total spells, but we don't know if they're all available or not. Okay, so this is how the computer finds out. It's just the one line here. So we're going to say if spell A, and if spell A equals 1, so all of these do, alright, then print at P. So if you use print at and you use number, you could print anywhere on the screen. I want to stay on the left hand side, so it's going to be multiples of 32. But we're going to print at P, and then you have to use a comma. We're going to put our string spell $A which is where we read the data right here. Okay, spell $A. And then we're going to put a space. And we don't need quotation marks. Strings don't need quotation marks. Otherwise, you'd have to put quotation marks and some a word. I can't think of what I'm trying to say here. You'd have to put, characters in quotation marks, a word or something. But here we're not, because by the design of this, it's already taken care of. Like if it were a $, it would just be a string. It would print the string. And we're going to pick I have this as arrow 2, so it's just going to be the flat side of the arrow, not denoting anything. And then apparently I need this. I'm not sure why. That is going to clean up the edge. And now I'm going to put a colon there, which is going to start a new line. And this is just to fix everything up. We have something called slot $, slot $y. So I made y equal to 1. Our first slot is going to be equal to spell $A. So our first slot is going to be our first spell $A, and this is so that we know which. This is how we make a relationship between the cursor and the spell to the computer. So now the computer knows which slot it's in and what spell is there. And now we have to set P equals P plus 32. So we move down one line, and as well Y increments by 1. So now Y equals 2. And we keep doing this until we get through all of the spells. So now we can see this on the screen. We have our partition right here to keep it neat. P it would equal 0. It starts at 64, or print at. Then it goes to 64 plus, is it 32? Would equal 96. And then 128. And then 160 down here. If I'm doing this correctly, 30 by 32s. And then we're showing our flat arrow, not denoting any particular spell. But that needs to be there because it's an eraser. This isn't perfect, but this is the best I could do as a novice programmer right now. It does the job. So now we have to continue this here. So I print at the position the spell, and then the portion of the arrow that is the eraser, And then we define slot Y as the first spell. So now the computer has a relationship. And then we just move everything down until we get to the end. And now there's something called last that needs to be in there. And this is part of the relationship. Last equals Y. And they're both numerical. So last has a value of Y, and we will end in a position that has nothing, and a Y that has nothing, but it will be equal to last. So I'm trying to, this isn't the easiest thing here, but let me just leave it, let me just take my word for it right now. I don't remember exactly, but I'm making this video so I can work my way through it back to where I started several months ago so I can make this game. And this is an important factor. It's not flawless, but it does work. So, so we're going to say print at, what am I doing here? It's going to be always print at P. Wait, hang on a minute, guys. I skipped something here. I'm going to put slot Y, which is actually slot 3, because there's two. Once this runs through here, we're going to have an Y is going to be equal to 4, even though we only have 3 spells. This is going to be equal to 160, so they're both empty. So at that final slot Y, it's actually slot $, I'm sorry, it's a string. Slot $Y is going to equal arrow $3, which was the return statement that I put as part of the arrow. I don't know why I did it that way, but now we're going to print at P. We're going to print at P, which is 160 slot Y. Slot $Y right now Y equals 4, so that's going to show us the return, and then we're going to do arrow $1, which is where we start our punctuation of the arrow. And I have to clean that up. So we can see that I should have a space here to show that it's different from the spells, but I did it this way, and I'm learning as I go along. But we start our arrow at the return. We don't start at the spells. So This code needs to be changed a little better, a little bit to make it better, but I'll do that in the future. I'm trying to reacclimate myself with this process, and I'm including you guys in it, so that you can see how much work actually went into this. So our last thing here is going to be our up, down, support, because right now there's no way to move that arrow around. We could move it around, but we had to make a relationship between the arrow and the data on the screen, which is done with slot $. And so put we're gonna put I $ equals in keys, and I usually use I $ because it just translates. You can use any string, but they usually use I $. So we're gonna say that if I $ equals up, and up is just by pressing the up arrow, but there's no down arrow, so you have to use shift. Shift down, because it doesn't have a keyboard value. I don't know if there's a hexadecimal or a control function. I don't know. But so I have to use shift to make it go down. If you guys know how to get the down arrow to function, let me know. It doesn't function. So we're going to say if I $ equals up, then y equals y minus 1. So we're going up one step. But then we need to print at P. And what we're going to print at P is slot $ y plus 1. So we're going to be printing just below where we're going to in order to cover up the original arrow. So we're going to have to cover up the original arrow first. That's why it's y plus 1. So we're jumping up 1, but we're actually printing over it. And we want to print arrow 2 over the arrow to erase the arrow. And then we clean that up, and we print our actual arrow. Okay, so the next thing, so we covered that up. Now we need to say that P equals P minus 32, like we did with the Y. We just need to make that statement. And then we need to print at P slot $ at Y, which is the true value of Y, and then a space in arrow $1, which is the arrow going to the left, so we're pointing towards the left. And I just want to clean this up, and by cleaning this up, I mean I'm putting a semicolon there so that when I go up, and it's not working because I have to make it a loop to in keys or it won't work. But you can see now that I'm going up, and the arrow, first it erases this, then it applies the arrow. Let me do it again. I can't go back down because it's not in there yet. But we're here. We push the up cursor, the up arrow. Now we're on evaporate, then kill, then move mountain. So now we need to make it go back down. And we're just going to do the opposite of what we did there. If I $ equals, now guys, tell me how to do this. If I just want to use the down arrow, nothing happens, so I need to use shift and down. If there's a remedy for that, let me know. We're going to say y equals y plus 1, because now we're going down. And I'm going to end the video right now after we do the up down, and then I'll do a part 2 where we actually have functions for these spells, because this video is I have to get going. But so I'll have a part 2 of this, I promise. So we're gonna print at P. And since we're going down, Y increased, so we need to print at P slot $ Y minus 1 arrow $ the eraser, which is 2. So even though we're going down, we're going to print at the previous slot arrow 2, which is, and we're going to clean it up, the portion of the arrow that is just the dashes. And then we're going to say P equals P plus 32 to get to the location that we want to be at. And at that location, we're going to print at P slot $ Y. Y is the true location of Y. And at that location, we want to print our arrow 1. Then just clean that up. And that's it. So when I run it, and I need to put, oh, that's all set. When I run this, I can go up. I'm pressing the wrong button here. I don't know what I'm pressing. We can go up, but now if I hit shift down, we can go back down, but it's not really working right, so I must have made some mistake here. Yeah, and I don't know why that's happening. Let's see, then why? Oh, I have a mistake right there. It says y equals plus 1. It should say y equals y plus 1. So I can go up, up, and back down. See that? Up, and back down. And I can literally go all the way down here. Except when that happens. I can go all the way down so I could have more spells, but they're not available, and I don't want to go there. So I have to put stops in here to stop it from traveling so far. But I can go up and down, And then when I get to the spell that I want, I hit the space bar, which has no function right now, which I'll do in the next video. And this is where a relationship will come in with a slot. It'll know which slot evaporate is in, and it'll handle the spell from there. And that's all there is to it for this video. And I'll do the rest next time. So this is how, when we try to cast a spell, we're going to go sub to this routine, which is called, spells. And I have a restore statement, so when we're done, we can read the data again. But that's how it works. I don't even understand the whole thing because I wrote it so long ago. But I'm trying to get reacclimated here to what I did back then. And I can follow most of it. I'm sure with when I have time to analyze it a little better, it'll make more sense. But that's it. I haven't heard from you guys for a while. We've been slowing down here a little bit. I don't know why. I don't know if people are busy or what, but try to post some comments. I don't know. Curtis wanted me to put Septandy, and I'll try to do that on this video. I'm not sure what that is. I asked him. He didn't reply. Not sure what Septandy is. It has something to do with September. So we're still in September, and I'm going to do that to see if we can get more views coming in. It's a hashtag Septandy, I think. I'll have to double check. But so that's it for right now. I'm actually going to save this for my own reference. I have a copy, but I'm going to save it anyway. And then I'll be done with this video. And this is just going to be called, I'm going to call it menu scroll. It's for my records. And I'm going to see save. I'm just going to put it menu. I guess menu. I don't know. I'm going to save that. And I'm going to list it out, and you can print using Xroar. If you want to know how to do that, I have a video on that. Check that out. I print to a text file, and then I list it out virtually. It prints to a text file, and then I'm able to print it out, review it, like I was doing for this video. You need a list. You can't write these big programs and not have a list printed out. So that's it, guys. Take care, and thanks for watching.